Well, hello everyone. So this is kind of funny because we can't hear you, but I know that everyone's listening. So welcome to our session. I'm super excited to be here today moderating this session. We just had a session with Frederick Abal talking a little bit about the changes going on in the energy world, not just the utility industry, but the energy world. And we have an excellent panel here for you today to have a little dialogue and interaction. And I just wanted to first of all thank the colleagues for coming and spending the day with us, and introduce first the panelists. So first we have Marco Gazzino from Enel with us today. We have Steve Cox from ENWL, network operator. We have Sebastian Henry from RTE and the German network, Antoine Jourdain from Nedis right here at home, our host, and Michael French from E.ON. So gentlemen, thanks again. As we started a little bit chatting before we came on to the session, one of the comments that I made to our guests was that, having been in this industry now for over 25 years, it is just really an exciting time to be part of the industry with all of the changes that are going on, right? When we talk about all the changes in bulk generation, merchant plants going out, decarbonization of the bulk generation system, the rise in all this renewable energy generation, all these changes that are going on and happening around us. So, that's really the framework of our conversation today. And so we're gonna put out some topics, and we're gonna have a little exchange. And we're really interested in hearing from you. How are your companies facing some of this change? What are your perspectives on it? And one of the first topics that I wanted to put on the table for our discussion is, as we see this, the energy mix changing and the scaling of renewables, whether it's solar, wind, whether it's bulk renewables or distributed renewables, as you see that that energy mix changing and scaling, what are some of the key challenges and opportunities that you guys see in the networks that you operate, right? So look, I'll just put it out there and see who wants to take the first stab. I know that we're very fortunate because some of you are living this in a pretty big way. So I'm very enthusiastic to hear your points of view.
Maybe I can start with few comments on that. Of course, renewables are a top priority for everyone. Enel in particular is committed to become carbon neutral by 2050. We have announced that more than 2 years ago, so it's well known, and we are on the path to achieve this target. Of course, renewables are a key element in order to do that. We install every year gigawatts of renewable power, and today about 60% of the installed capacity is carbon-free. Of our installed capacity is carbon-free, and almost 50% is from renewables. This means that the complexity related to manage more and more renewables into the grid is becoming more important, and flexibility is a key issue. Storage could be one of the solutions. It's not the only one. One another is adding intelligence to the grid, which is very important as well. And maybe it's important to do both, not to rely only on one solution, but to rely on multiple solutions, because just one solution cannot achieve the goal, let's say. So standalone storage or grid-tied storage is important and effective, and adding intelligence to the grid is very important. And this second option is also relevant for another reason, not only because make it possible to leverage on distributed resources in a more effective way, but also because can bring into the equation the customer, the capability that the customer and the resources that the customer can provide to the grid for balancing it. So it's very important to think about in terms of exponential growth of distributed resources which are going to be owned by the customers, and the capability to get access to those resources in an effective way and to orchestrate and to aggregate those resources in a way which is effective for the grid is very important.
Good, thank you. Antoine.
If I may add a few points. In France, it's a huge opportunity for the distribution network. As it has been said in the previous session, the renewable are growing a lot, and in France, 95% of the renewable are connected to the grid. And the grid was not built, was not designed in the past to integrate any renewable. It was just from central production to the customer. And now, with for a region like Champagne-Ardenne or Picardy, for example, in the east or north of Paris, you have some days 20 to 30% of consumption, which is renewable, which are produced locally. So you can see that the grid, which have to link this production to the customer, which has not in the past been built for such a mission, have to be totally redesigned and to become smart, to be able to integrate all these new activities. So for us, it's a huge opportunity for new capacity, for new work, for new jobs, because we, as it has been said in the previous session, we have to connect all these points one to one to be sure that at the end, independently of the weather, of the wind, the customer has always the same quality of electricity, because whatever is passing on the network, the customer wants always the same quality of electricity. On the other side, to connect all this renewable, we have to reinvent new way to be quicker, to be smarter. For example, our HV/MV substation have to be much more clever, much more smart, to be sure that when the voltage is going higher on the grid, we are able to connect with algorithm the grid to the HV/MV substation to be sure that the voltage and the reactive power is at the correct level. And we have to develop a new way to connect and to integrate our customer, which are the producer now, because it's a new customer for us, the producer which are owning windmills. We have to connect them quicker, and we are developing some project with some modular HV, MV substation, which are just on trucks, and that we are developing such a product so to be sure that in a few months we are able to connect the maximum of renewable, because today in France we are about 20 gigawatts of renewable, and we have to double this part in the next year. So for us it's a huge opportunity of the technical part, and to be a real enabler for all the collectivity and of the French territory.
Antoine, what do you, just follow up on the point that you made right now, as you do this integration and the volume starts going up, what are some of the critical points in terms of maintaining reliability of the system as you drive this integration?
The main point now is becoming to be to be online. We have developing some tools which are able to connect, to reduce the power, or to adapt the power of the production to the consumption. Mm-hmm. So because in some countries a lot of renewable are connecting directly to the transmission, so it's a different issue. Mm-hmm. But in France, you have some besides some windmills, you have some customers which are linked on the same network. So you have to really have online, and so you have to have captures which are linked, which are developed by some of our partners, mm-hmm. And are directly linked to the HV/MV substation, which are able online in a very few times able to adjust the network to the power. Mm-hmm. to the power.
Yeah. Okay. Yes, Mike.
Okay. Maybe I talk next. We talk about the change in the Energiewende, as we call it in Germany. If disruption comes as a wave, I would say Germany's been at the front of taking that first hit. It's really had a massive effect on where we are, and you can see that by the changes. I mean, us as a company, we've gone from vertically integrated, we've cut off the top, we're now moving into horizontal consolidation. I think the EU has a target of getting 27% of the energy from renewables in 2030. In Germany last year, we already had 33%. So we're already living in the post-2030 European world. For us, we've got 20% of the grid areas in Aeon today, but we have 35% of the German renewables. So we're nearly double where Germany is, which is already post-2030. So the revolution that's hit us has been very strong. The level of disruption has been very hard. And the key to it is flexibility. And it's not about flexibility of the grids, it's flexibility of your organization, of your people, of everything else to really make that work. That has been very tough. So in the north of Germany now, some of you may know some years ago, we had a lot of wind coming in. There was so much energy coming into the grids, far more than being consumed, far more than we could push through Germany, and by default we ended up pushing it east across into Poland. And this messed up the Polish grids. They then pushed it south into Czech. This messed up the Czech's grids. They then pushed it west into Bavaria, and finally we got our energy from the north of Germany to the south. This is not the ideal way to do it. And we're putting, there's lots of efforts to try to build these north-south connections, but politically these things are always very difficult. So the disruption that's hitting us now is enormous. And in the area in the north where we had that problem, we've now produced, last year, we produced from renewable energy 25% more than we consumed. So it's not about a peak day or a peak thing. For the entire year, we produced more energy from renewables alone than we consumed. If that was an island, you've basically got, well, what is that? Does that mean free electricity? It certainly means guilt-free electricity. You can just switch the air conditioning on and leave your windows open. It doesn't matter. You've got more than you need. It's clearly not an island. We're then shipping that across into the different regions. So the issue that we have is the disruptions come so fast, the solutions are not yet there. So of course we need a lot more flexibility. We need to have a lot more control over switching on and switching off sources and uses of power. We need to be much smarter in moving ourselves around the grids. But for that you need the technology, you need the regulation, which is a really important barrier. And that's coming, but it's not coming fast enough. So that makes it very expensive to absorb that energy.
So in terms of curtailment, you've had to do a fair amount of curtailment in the available generation, right?
Yes, for the reasons of the local piece, there's a fair amount of curtailment. At the moment, we can still cope and push most of it into the rest of the grid. But that curtailment issue, of course, locally will grow. Solutions such as storage in the grid would be great. Unfortunately, the regulation in Germany, we can't do that.
Doesn't facilitate
it does not
that,
allow the DSO to put storage in the grids. So we have a little bit in Pelvorm, we have a test, we do some stuff in Sweden, in the US, but we cannot do it in the most economically efficient way. And it's always a challenge for the regulator. How do you allow competition in a world that's moving faster than you can think? This is tough.
Okay, good.
Okay, from the UK perspective, I think echo a lot of the points in France and Germany. Renewables are connecting in very large volumes to distribution networks. So we have a maximum demand of 5,000 megawatts, and we already have 2,800 megawatts of renewable generation operating every day on that network. So we're just over the 50% point in terms of renewable penetration. One of the key challenges for customers, because this is all about customers, it's not just about energy, is affordability. If we look at, can customers afford the bill? So we have to make the grid operate efficiently. And if we look out to 2050, when the decarbonisation journey should be complete, 80% of the network is already there, that will be there in 2050. So whilst we can augment the network with new technology and we will change some components, most of the network needs to be made smart that customers are already paid for. We would probably forecast within literally months all of our transmission connection points to the national operator in the UK will be operating in reverse power flow, and we've reached the transmission system's capability to accept exported renewables from the distribution system, particularly during windy weather or high solar output. So the UK transmission operator is facing the same problem. You mentioned before reliability. Customers, particularly as they move to electric heat or electric air conditioning, or particularly using electric vehicles, demand ever higher levels of supply reliability.
Yeah.
So that for us has driven two key responses to the challenge. First is a huge rollout in network automation in Schneider. We now have nearly 45% of all of our substations, so we have 40,000 substations. 45% of those now have SCADA to allow us to control the power flow and reconfigure the network dynamically. And the second major investment for us is in the integration of operational technology and IT to give us a full view of the network capability and dynamic control of the network. So we're currently implementing the Schneider ADMS system and driving forward some of the active network management development, and that's a key IT platform for us as we seek to solve that problem.
How do you, what's your thinking in terms of how does planning and forecasting at the distribution system level evolve, and what do you see as some of the challenges at the distribution level that come into play now?
I think a couple of the speakers have talked about flexibility. So when we look at our large industrial commercial customers, say a cement plant or a steel plant, they are now selling their flexibility to the transmission operator for frequency balancing and system balancing. So it's ever harder to forecast what large power consumers will be doing, because there are many players in the market who are altering power take or generation output. So we see typically storage installations in the UK are 50 megawatt installations. We have several now connected to the network, and they will operate very dynamically. It's very difficult to forecast what they will do because they have many commercial relationships with aggregators, suppliers, generators, and the transmission operator.
Yeah, it's key.
So yes,
Sebastian.
I will just give a few elements from the side of the transmission side operator. So of course the energy system is just at the beginning of a huge transformation. We have seen some figures from our German colleagues. For the French system, we have a fast development of renewable energy, and we plan that what we have today will be multiplied by 4 in the next 15 years, not 15 days. and at that time, so we have more and more renewable production, and we phase out also some thermal units, some coal units, and there is the question of nuclear units, also a diminution of nuclear units in France. So as a consequences, there are different consequences. First one is a huge change in the power flows. Local power flows, that was explained by Antoine for the distribution side, regional power flows and European power flows, as it was said before. So there is a huge modification on the way we operate the system. And with this change of power flows, that implies modification on our infrastructures, and that was also said before. The infrastructure we have now is maybe 80 or 90% of the infrastructure we will have in a few years. So when we speak of flexibility, there is the first question of the flexibility of the infrastructure, and the huge opportunity we have is the combination of the digital transformation and the electrical transformation. We see here many opportunities and innovation that are now available in order to better manage the assets. So there is this question of transforming the electrical infrastructure using what is the best of digital transformation. And the second huge change is related to the balancing of load and generation. So of course, with the insertion of renewables, we have more and more questions around the balancing of the system in real time.
Yeah.
So just to give a figure, today, on a normal day on the French system, we move 60 gigawatts during the day compared to what would be the natural behavior of the demand and of the generation. If we foresee the situation in 10 or 15 years, this figure will increase a lot and we'll have to move more than 100 gigawatts per day. So this is the space for flexibility. As I said before, flexibility should have to be addressed on all the demands, from demand side, from storage, from infrastructures, and from generation. So that's, I think, a huge challenge for the system.
Yeah. This theme of flexibility is a super interesting one. Maybe you elaborate a little bit on this in terms of the solutions that you're implementing or that you foresee implementing in order to generate some of these flexibility. Maybe if we could elaborate a little bit as to maybe some of the demand side programs that you might be putting in place at the end user, at the industrial, and maybe some of the supply side programs that you might be looking at. There's a lot of different tools. Some of these are very, I think, dependent on the regulator and different policies that come into place. Maybe if we could hear a little bit on in terms of what you see specifically in how you achieve flexibility and how you deploy programs around flexibility would be very interesting.
One example that we have implemented is it's about taking this flexibility from electric vehicles.
Yeah.
Enel is betting a lot on electric mobility and in general on the uptake of the electric vehicle markets. So we believe very soon much more electric vehicles are going to be available around the streets. And the battery which is inside the electric vehicle is significant both in terms of capacity and power. And if we use that battery in order to balance the grid instead of just letting the electric vehicles charge and then doing nothing when parked, this is a significant resource. This is the so-called vehicle-to-grid, which is a form of smart charging. And we have developed a platform which is called JuiceNet, which make it possible to carry out smart charge when electric vehicles are connected to a charging station. And this is quite significant both for the grid and for the customer, because the grid that way may have an additional flexibility resource, while the customer can be provided with an additional revenue stream arising from making it possible for the operator and for the aggregator to get access to that asset. I mean the battery which is inside the electric vehicle. We started this concept with pilot in Denmark 2 years ago. It was not piloting the technology, actually. It was piloting that concept on a commercial basis, but small commercial basis, and it was quite successful. We partnered with Nissan and with EnergyNet DK, the local TSO, in order to do so, and also the customer was quite responsive, and the program was successful. And now we are scaling up the smart charging mainly in United States, with a particular focus in California and United Kingdom. Mainly because they are very good markets for electric vehicles, but also good markets in terms of balancing services and the readiness of the regulatory framework to accept this kind of new services, which we believe are going to be more and more important in the near future for grid balancing.
Yeah, I mean, Southern California is looking at having 7 million electric vehicles, which would be about 24, 25% of the vehicle fleet by 2030. So, I mean, it's reality that's coming, right?
Absolutely.
Yeah. Anyone else?
I think there is different types of flexibilities. There is a very local flexibilities, and for example, in France, we are implementing our smart meters, Linky, what we call Linky, which is able to really manage local flexibility. That means that when you have some prosumers and with collective prosumers you have in a building, you have some PV on the roof, and the people want to allocate their production and to their consumption. When they are on holidays, they don't want to consume because they are not here, so they want to sell it again to the other people of the building. So it could be, let's say, and this has an aspect on the network. And in fact, with Linky, with all the service that we are offering with this smart meter, we are able to launch some activities. For example, it's an old story in France, but you can launch your boiling system for your hot water when there is a lot of sun, which is able to really manage a very local flexibility.
Yeah.
Second, you have the one of the on the medium voltage substation that I've described before. And what we see really for Enedis on the flexibilities is really the way to maximize the usage of the network at this maximum power. In one sense, or in the other. Today, sometimes with the curtailment, we don't manage so much curtailment. But maybe the curtailment, if you are always overbooking the network, the curtailment could have an economical sense. Today it's not very popular because we want to increase, and so we think that on some aspects the network don't have to be reinforced. We don't have to spend capex too quickly. It's better to make some curtailment or to use the storage when it would be available at the last scale in France, and when the DSO would have the right to do something. It's a little bit moving on the EU stage. So we will see, and we are trying to implement all these aspects. And the key to implement all this issue is the on-time data. The on-time data that we have to manage and to be sure that we have the right data at the right place and the right tool the right interface to be able to manage in one sense or in the other direction the different usage. And you have described the vehicle electric car, which is the key issue in the next years. And you can see for the electric car, it's very detailed and it has to be really one small point by one small point. So it's a key issue.
Yeah. Okay.
Okay, thank you. Just a couple of other thoughts. I think when you look at demand flexibility now, you're really talking about large industrial and commercial customers who can shift significant amounts of demand. But as we go through decarbonisation of heat and we shift from gas to electricity for heating homes, and we move to EVs, then domestic demand, which is currently 1/3 of peak demand, will become more than half of demand. So the growth is not in the industrial and commercial sectors. Yeah. So if we look at that domestic sector, if our customers only buy 4 smart appliances, so smart heating system, smart vehicle, laundry, air conditioning or refrigerator, that means we will have more than 10 million connected devices in order to enable flexibility from houses, from homes and from small businesses. That is a huge challenge about how you do that. The second point is, from a regulator point of view, we've seen the European codes, the grid codes, DCC, RFG come in recently. Those codes do not allow network operators to force customers to respond. We can operate markets, we can put financial incentives, so As we've already heard, the UK has a very active market for demand-side flexibility, both for frequency and system balancing. We're launching a number of calls into the market for flexible response from customers. So we should presume that customers will want to earn money or save money by being in that market. So as well as the technology chat platform that understands what's happening on the grid, it's how you commercially reach customers to encourage that flexibility. So we talked before about 100 gigawatts of demand shifting, for example. That is a huge problem to reach that many customers. And the only way that can be solved is by automated systems which help in-home management systems, reach EV chargers, reach heating systems. So I think one of the challenges I would put back from the network operator perspective is we look for the supply chain, for the Schneiders, Siemens, Gs of this world. That is the market that you need to help us embrace and tap into commercially, so that we can allow customers to earn money from flexibility and help solve those problems.
The customer engagement is changing pretty significantly as we go forward, right?
Absolutely, yeah, absolutely. So
any thoughts on that, on how your businesses are evolving and how you see it evolving in terms of customer engagement? Right, any of you?
I take that one and we come next. Firstly, I'd like to support the point. The change is happening at the customer level. So it is going from, at the moment, we have the large commercial and industrial, and we have pumped storage and this sort of thing. And it is moving into the customer level, and it's also moving behind the meter.
Yeah.
So this is where the engagement will happen. So it means, first of all, if you're trying to balance the system and get the flexibility, you need to start at the smallest individual unit, and then you need to scale that up to a larger and add, and then you end up at the transmission grids. It's not in the old world where it's the transmission that starts first trying to balance it. So we have to go backwards. In order to do that, again, we need the regulation to make that happen. I think for the in front of the meter part, depending on the regulation, and we do some nice stuff in California where we have the batteries in the grids, and you can start, and that makes sense. And we can put them also, I think in the UK, we have batteries on with our power plants. So this works together reasonably well. When it comes to behind the meter, it's slower. We talk about e-mobility, and we also agree, and we push a lot into the e-mobility side. But practically speaking, if you're going to start to use the customer's car batteries and recharge and discharge that, it's the wear and tear on your customer, so they're paying for it. And if you look at the numbers now, it is difficult to make that work up. I think the charging of when you charge the battery, this is the trick today. This is good. How much you discharge and how you do it, you need to be very careful to manage the battery for your customer correctly. And for that, you need the data out of the car and out of the vehicles. And again, we don't see that we get the access from the car manufacturers to manage that data correctly. So there's a lot of regulation that needs to happen to allow us to do that at the working level and engage with the customers. Of course, so we have the e-mobility, we have solar panels on roofs, we have a product we call Solar Cloud. So you can take your solar, and without having a battery behind the meter, we will store it for you. So it's building, and it's coming, and it will be a key part of the future, but it needs access to data, it needs us to start thinking bottom up instead of top down, and it needs a regulation to support it.
Okay, good.
I will add a positive point of view on the evolution of flexibility coming from demand. I think parts of it is already really progressing every year. Last year, for some days, we have a few gigawatts available as flexibility coming from demand on some days. So things are moving. As it was said before, of course, historically, it's easier for big industrial customers. I see that there are many things in this room trying to add flexibility to the power plants, and that's something that is already happening because the business model is there, and I think the regulation is also okay for these kind of customers. Then there is the question that we need to address for the next years is the evolution of the business models more for residential customers and the adaptation of the regulation for that. We are always speaking of smart grids, but there is also the question of smart regulation and let the place for innovation also, because we need to test different models, and there is an organization that is moving between the different actors of the system.
Yeah, good.
If I just add a
Sure,
few
Antoine.
points,
Yeah.
there is for us there is a new kind of customer which is not totally new, but which is taking much more power. Is the big metropoles and the big municipalities. They want to play their card in the energetic transition, and they ask us to give them the service or the data that they can use to implement their own plan of the energetic transition. So, and because it's a distribution network, we have all the data of our customers, so we have to be very careful about cyber security, and we have seen what happened to Facebook a few days ago. So we are not in the same case, but the municipalities want really to have their own plan on how to develop a clean city, and they want to sometime to make some arbitrage between some flexibility between different energies, between heating plant or gas network. So it's a new customer. They have it's not a real typical customer that we have just one by one on which we can aggregate and we have a service that we can provide. They are really asking the service, and they are even designing the service sometimes. So we have really to procure on the technical side what they want, and also we can see in Lyon, in Nice, and in Paris we have some issue, and we are providing a lot of data to allow them to make their own plan for greener municipalities.
Okay.
If I can briefly comment on the point by Michael about the wearing of the batteries when the cars are connected to the grid, that's always something which is said when speaking about vehicle one grid, vehicle two grid, and it's true that if you do not do vehicle to grid, vehicle one grid, smart charging in the right way, this is a risk. But you have to think about that the power of the charger is usually lower than the power of the battery. So it's not the same. Using that battery is not the same as using a standalone battery, which is always at full power, connected at full power. And again, when you think about primary reserve services, which are the first one you think about when speaking about vehicle one grid and vehicle two grid, in that case, they are much more power services than energy services. So the life consumption of the battery is much lower than the one you may have in a standalone battery for other services to the grid at full power. So finally, the simulations that we have carried out have shown that the life consumption is so low that the customer cannot get knowledge about that on the lifetime of the car. Provided that the smart charging is done in the right way.
In the right way, Oh, go ahead.
Just one point following Antoine on the on cities. I agree. Cities are going to be huge players. So if we look at City of Manchester, for example, UK's second largest city and very good football team. The city does not wish to charge drivers to come into the city to make the air clean. They will install EV chargers, and if you drive an EV into the city, you can charge your car at no cost. The energy is free. So the cities are driving EV strategy. They will then control the chargers and actually sell that flexibility into the transmission market. So we're seeing cities which are not typical consumers becoming very large players in determining both strategies for EVs, where EVs will geographically go, stopping people charging at home because we have free fuel when I go to work. And thereby they create huge amounts of demand flexibility for vehicle to grid projects. So I think again, that is a key group which is emerging that we need to reach out to and help them with the technology strategy and the business model as they enter that market.
Yeah, I think
that will grow demand.
Yeah, I just recently had this same conversation in Toronto with a number of constituencies in Toronto as they look to see this major shift of EVs into the city. We covered a lot of ground here in terms of the distribution system. If you maybe share your thoughts in terms of, as you look at all these changes and you look at the different digital technologies that are necessary to enable this and enable this customer engagement, what are some of your thoughts in your own company's objectives in terms of prioritization and mission critical capabilities and applications that you're working on to win in this new world? Sure.
I think one of our, I mentioned before our recent investment in active network management and ADMS systems. I think our view is that within probably 10 years, possibly within 5 years, there will be so many participants acting on the grid, trading bilaterally with energy, offering flexibility, flexible generation and storage, that we will not be able to control the grid system with operators in control rooms. So one of our key strategies, which we're working with Schneider in Serbia on, is full automation in closed loop of the grid for network balancing and semi-automatic frequency balancing. So I would see that as one of the capabilities we must acquire in the next 5 to 10 years, or we will lose control of the grid. There will be so many moving parts, we will not be able to understand what is happening.
Yeah, the complexity is just exponential, huh?
Yeah, there is so much data. I talked before about more than 10 million connected flexible devices. You can't control that with people.
Yeah, I agree with that point. I think the first move we have is concerning directly our own infrastructure, so that there is a total need of a revolution in our control centers due to the numbers of actors that are now in the energy systems, the numbers of data. So we need automation, and we also need to transform our infrastructures. That's what I already said before. We need to use them at their maximum capability, meaning add sensors, add digital substations, and try to increase the value of our assets. So that's directly things that are related to the grid infrastructures. And on top of that, we have all what was discussed before on the engagement of the customers, but also of some new actors, cities, new groups of generators, aggregators, and so on. That means big evolutions also on all the systems allowing for exchange of energy, market systems, and data systems.
And for us, there will be a huge change, a huge disruption to implement in our dispatching system. Let's say we have 28 dispatching system in France, and so far they are much more focused on when there is an incident, how to implement the best way the customer. So with artificial intelligence, we have to this part of the job have to be much more automatic. So at the end, the guys who have to dispatch the network when there is a disruption in the past, they have to this part have to become totally automatic with intelligence artificial, and then these guys who have to manage the dispatching are really to focus on how to balance with all the new elements that we have described before.
Very briefly, priorities are essentially two. One is about the grid, keeping the level of grid automation and capability to get information from the grid at the top level For instance, we have also just started the deployment of the second generation of smart meters.
Yeah.
And we have already deployed more than 30 million of smart meters worldwide for our customers, and now we are starting to install the new ones. The first ones were installed about 15 years ago.
Yeah.
So, and we strongly believe on this kind of investments to ensure also the capability to address the second priority, which is focus on the customer. And provide the customer with digital services which are making possible to deliver not only for the customer but also for the grid requirements, new services like flexibility and all those ones which are arising from aggregation. This is the concept behind the recent launch of NLX, which is our new business line, which is 100% focused on that, and also the rationale behind the acquisitions of Enernoc, Motorworks, and Demand Energy Network, which are exactly on the value chain of demand response and aggregation end-to-end from the grid to the customer, covering all the supply chain for this kind of new services.
Tell me a little bit about how, with all these dynamics and change in flows and actors that you're dealing with at the DSO level, what are your thoughts around cybersecurity, and how are you thinking and planning for all these new actors into the data networks that you have to operate the grid?
It's a tricky area because you know that the electric systems are not built today. They of course have a legacy of a long history, and you have old systems to be updated with the new ones. And also in the future you are going to have more and more different systems which need to speak each other also in an IoT environment. So those systems are going to be much more open than they were in the past. And as soon as a system is open, also the cybersecurity risk is higher.
Big deal, yeah.
And I think we need to find the trade-off between the business need and the cybersecurity risk, and also to anticipate the cybersecurity attack. What we have done as Enel is to open a computer emergency response team 1 year ago. We installed the sensors in the grid in order to identify very early if anyone is attempting to enter into the SCADA system and penetrating into the different systems. And this is very important because as soon as you get notice of that early, you can take countermeasures which are effective.
Great.
And I think that's an area which is going to be more and more important also. It's important today, it's going to be more and more important in the even more in the future.
Yeah. Good.
On cybersecurity, I think there are two different parts. There is one which is linked with the systems we directly operate as grid operators. So we have the question of the old legacy system in which we need to invest at least for additional cybersecurity functions. So that's a question that is addressed to all the system operators. And the new question is related with the huge number of actors that may interact with our system. If we speak of devices that will be behind the meters, we can have millions of them, and then there is a question of standards of certification of these EGEMs, because of course the access to such device will be easier, and with the cascading effects we have on the system, so it's vital for us to be sure that cybersecurity is embedded in this system. So that's a question for our industry.
Yeah. Great, thanks. Let me wrap up with just one question for everyone. Just give me your observation. When it comes to regulation, as we look at 2018 and right in front of us, What is the most impactful piece of legislation that you're following in your jurisdictions?
If I can pick two,
Yeah.
I would say the European network codes have a massive impact on what businesses do, the role of aggregators, who can own storage, what is a DSO, so the emerging DSO function.
Yeah.
I think also data privacy legislation is hugely important for customers. So we should not presume that we can tell customers what to do, or we can even see their smart meter data. You know, that is a relationship we need to build trust in to have access to that information.
Yeah. Good. If anyone else had a thought?
Sorry, but I would just have exactly the same too. I mean, it really is that. It's what can a DSO do and what can a DSO not do. I mean, we've stopped using the word distribution. Internally, we use network because we're not distributing central energy. We're networking sources and customers together.
Yeah.
But you can't do that if you look at what's happening in the European code. So it's moving in the right direction, but not all of it and not in the right way. And the other thing is access to the data. We come back to the similar problem with the car battery. If we don't have full access to the data, you can't use the really smart charging that we're talking about.
Okay.
Those are the two critical things.
And I think that in Europe it's have moved the last years with EDSO, which is really taking care of our problems. And I think in the past the DSO were not considered as a real actor of the system, and now you can see that all the distribution, all the decentralized production is growing a lot. When you can see when you all what you have discussed about, and so the DSO is really the heart of the energetic transition. So it have to be we have to be more and more the heart in complementary with the TSO, and that we have to be complement and we have to work well together. But it's not we in the past we had a minor role, and I think we have the first place in the energetic transition. Or we have to share. I don't see.
Well, Antoine, I think that's just a fantastic way to end the session. We see that the DSO is at the heart of the energy transition. It is one of the fundamental elements of this migration that we're going, and it's a super exciting time to be a part of this. So, look, on behalf of Schneider Electric, thank you so much for joining us, and thank you so much for sharing your insights with us today. It's been a pleasure. Thank you.